Okay, so this lesson here is to cover systems of linear inequalities. So before we get going on this, I want to review graphing for one quick second. So remember, we've got basically two forms of graphing. We've got y is equal to mx plus b, where m equals the slope, okay, and b equals the y-intercept. Okay, when you graph those, that's something like y is equal to 2x minus 3. When you graph it, 1, 2, 3, you've got a b is equal to negative 3. So we anchor it here at negative 3 on the y-axis, since b is the y-intercept. And with our slope being 2, m is equal to 2 over 1, which means we go up 2, 1, 2, right 1, and there's our point, and that's how we, well, let's actually connect the dots. That's how we graph our line. That's one way. The other way to graph the line is if we go standard form. Remember, standard form is ax plus by equals c. Okay, to do this, we use intercepts. We find the x-intercept and the y-intercept. And so I've been told that some of y'all have learned this way, where we make a table and we do x is 0 for one and y is 0 for the other. So if I was graphing something like 2x minus 3y is equal to 6, I can make my table and I can find when x is 0, I get negative 3y is equal to 6, or y is equal to negative 2. And when y is 0, I get 2x equals 6, or x is equal to 3. And to graph that, we graph it using our intercepts. We've got 2 points. X is 0, negative 2. So we got a y-intercept of 0, negative 2, and an x-intercept of 3, 0. And we connect the dots. Okay, so that's our quick overview of graphing. Let's actually get into what we're covering today. Our objective here is to graph linear inequalities in two variables and systems such inequalities. Basically, we're going to graph linear inequalities. We're going to have to shade. So our definitions: linear inequality in two variables. A sentence obtained by replacing equal signs in a linear equation by an inequality symbol. We've got a couple of examples here. 4x minus 7y is greater than or equal to 5. X is less than 9y. The solution of an inequality in two variables is an ordered pair of numbers that satisfy the inequality or makes it true. For example, 5, the point 59, the point 00, the point negative 1, 2 are all solutions of the inequality. Let's investigate that for a second. Okay, so let's just take one of them. If x is 5 and y is 9, I get 9 is less than or equal to 2 times 5 plus 4. 2 times 5 plus 4 is 14. So that is indeed true. Or if y is 0 and x is 0, we get 0 is less than or equal to 2 times 0 plus 4, or 0 is less than or equal to 4. That one's true. We can even check if y is 2 and x is negative 1. I get 2 is less than or equal to 2 times negative 1 plus 4, or that's negative 2 plus 4 is 2, so that checks out. That's what it means by solutions. That means they satisfy the inequality. An associated solution. Here's a new word: associated solution, or associated equation. Oops. We want to associated equation. The linear equation obtained by replacing the inequality symbol in a linear inequality by an equal sign. Example: the associated equation for y is greater than 2x plus 5 is y is equal to 2x plus 5. So we can associate the equation. This is actually the boundary. Okay, so they introduce the word boundary on the next one. Open half plane. That's the set of all points on one side of a given line. Okay, we call that given line the boundary. Okay, the boundary appears as either a dashed line, because it is not included in the graph. That's an open half plane. For instance, if I graphed this and I have a dashed, ooh, and I have a dashed line and I shade above, that would be an open half plane. A closed half plane, we have a solid line and we shade one side. That's a closed half plane. Okay, so again, the open half plane, the closed half plane. All right, so here's our closed half plane. And then a system of linear inequalities means we've got a set of linear inequalities in the same two variables. The graph of such a system is the set of all points satisfying all of its inequalities. So let's look at our examples. The first one, we want to graph x is greater than -1 in the coordinate plane. I want to shade. Okay. Graph x is greater than -1. So let's look at the associated equation. X equals 1. X equals -1. So x equals -1. Well, x equals -1 here. It also equals -1 here. It equals -1 here. -1 here. These are all the different places where x equals -1. We have no y restriction. Now, I know x is equal to -1. So what I know is if I have less than or greater than, that means I have a dashed line. So in my case here, I have a dashed line. Now, I also have the statement for my first one that x is greater. Well, what numbers are greater than -1? So when x is greater than -1, that implies x could be equal to, I don't know, 0 or 1 or 2 or 3. Those are all numbers on this side. Okay, so what we find out is this is where we can shade. All of the numbers on the right side of this line solve our solution, solve our linear inequality. Now we've got another one, harder graph. 3x minus 2y is greater than or equal to 6. So we're going to do this with the intercepts. I'm going to make my table. We're going to do x, y, okay, 0, 0. So let's just take this, and if x is 0, that makes that go away, and so I get y is equal to -3. If y is 0, it makes all of that go away, which means x is equal to 2. Okay, so I have intercepts. My intercepts are 0, -3. 0, -3 is the point right here. 2, 0 is the point right there. Okay. Now, I need to figure out, is this a closed half plane or an open half plane? Well, what we're going to do is we're going to look at that sign. So much like when we were doing systems of linear equation in one variable, if I have greater than or equal to or less than or equal to, that means it is closed, i.e. a solid line. So that's what I have. I have a solid line. Okay, now I need to decide, am I going to shade above or below? Let's look at our equation. 3x minus 2y is greater or equal to 6. If I know its y is greater than or equal to, or if I can break it down to y is less than or equal to, this means if y is greater than or equal to, we shade above. So these right here mean we shade above. Because y's that are greater than are larger. That means up on the y-axis, so they are above. Y is less than or equal to, means we shade below. So if I can isolate here, I want to know what y is. -2y is greater than or equal to 6. Well, I don't have y isolated because I still get that -2, but when I divide by -2, what happens to my inequality? it flips. So y is less than. Y is less than or equal to. That means this one. That means we shade below, and so we shade below. Up here is above. This is below. So that's where we shade. Okay, so a caution here. Don't assume that we should shade below for an inequality having the symbol less than, and above for the symbol having greater than. Now this is why I make the distinction. We want y is less than or y is greater than. We want y. Okay, we got to have y is. We can't just look at the inequality. If I get y by itself, that'll tell me. There is a safer way to do this though. We can test a point. What that means is we'll take a point and we will plug it in, and if it satisfies the inequality, we shade the region containing the point. If not, we shade the opposite region. Okay, so here's some problems for you to try. Okay, so we'll look at those in class tomorrow. We want to graph another one. This is two systems. Okay, this is 2x plus y is less than or equal to 2. So I'm going to take that and I'm going to solve that. I'm going to get y by itself. So 2x plus y is less than or equal to 2. I'm going to take that, subtract the 2x, and so I get y is less than or equal to negative 2x plus 2. I'm going to take the second one. X minus y is greater than 0. I'm going to do this a little bit differently. I'm going to add the y. When I do that, I get x is greater than y, or I can rewrite that as y is less than x. So what this means is I can do this in slope-intercept form. For instance, here, this one. I'll do this one in blue. M equals negative 2 over 1, b is equal to 2, so that's what I'll graph. B is equal to 2. Negative 2 over 1 is down 2, right 1, down 2, right 1. Or we go up 2, left 1, up 2, left 1. So we go down 2 or up 2, left 1, right 1. We connect those dots. Okay, and that goes that way. I know it's solid because it is greater than or equal to. Okay, that makes it solid. And y is less than or equal to means below. Okay, so below that line would be on this side. Now let's look at the other line. Let's do it in green. Y is less than x. So m equals 1, b is equal to 0. Well, that makes it easy to graph. Y-intercept is 0, 1 over 1. 1 over 1, 1 over 1, down 1, left 1, and so on. It is dashed. It's dashed because y is less than. So we've got dashed, and again, y is less than, so that makes it below. Okay, so if I shade below, that's over here. Now where do they overlap? They overlap in this region here, and that's where we shade. Okay, so again, we've gotten y by itself on both of them. We've graphed both of those using slope and y-intercept, the associated equations. All right, and then I shaded appropriately. Okay, we want to note that the points on the solid boundary, okay, note the points on the solid boundary are part of the solution. The points on the dashed boundary are not. And I believe the rest are problems for us to work in class, so we'll pick those up again in class. And we are done.